pi is 3.14, right? 180 degrees is 3.14. So now we need to convert that so that we can treat radian as real numbers. So now, as you know, the area of the sector was pi r squared theta over 360 degrees, right? But this no, not pi, this is theta, I'm sorry, theta over 360 degrees. But theta here is not in radian. Theta here is in degrees. So then we need to convert that into radian, right? So first, 360 is 2 pi. Therefore, pi r squared times 2 pi over this theta, right? This theta, we do not know. We do not know. We do not know that because we just say that this is theta prime, right? But what happened here is theta times 180 over pi is theta pi. So we converted radian, not radian, a degree. This is a degree here, degree into radian here. Okay, we did that here. Okay, so well, this is better explained by an example. Well, I'll do so soon. So here, arc is 2 pi r times theta over 360, right? But as you know, this 360 is just simply 2 pi, right? Then we need to convert this into radian as well, right? Radian. Let's just say that this is also theta prime, which is this here, theta prime. Then this is just simply 2 pi, 2 pi, they cancel each other out. Then we have r times theta prime. So this is really, really important formula here, theta prime. Okay, so this is better done by, better explained by examples. So the difference between theta and theta and theta pi over here are theta. Theta is a degree, whereas theta pi is radian. So you need to convert that into radian so that you can mess with, you can have this theta prime or theta mess with real numbers, okay? So the important formula here that you need to know is the second one, okay? So now, assuming that you know all this, well, I'm not going to erase everything, but I'll erase important, not necessary part. From here to here, I'm going to erase this, all right? So I think, hey, Christian, I'm making this. This is the third time I'm making this because I mess it up. Like the first time and second time, I mess it up. So it took me like a lot of time. So it's just my silly mistake, you know. Well, anyways. Oh no, that's not what I wanted. Okay, I just want to delete this part. Yeah, like this. All right. Oh no. Okay. So here, let's solve 33 together. So 33, I assume that you read the question here. So you have two circles. And so concentric circle just means that you have two circles whose centers are exactly the same. Okay, so something like this. So I'm doing 33 here. So now you have R1 here is, okay, no. You have radius of a smaller circle and a bigger circle. And then since you have sectors, like this. Okay. And then now they're not really drawn to scale, but well, anyways, R1 is 11, R1 is 11, and then the bigger one is 44, right? and then what is given is that this is 9, the arc here is 9, and then we know that we need to know this arc here, that we need to know this theta here, right? This is a central angle. So first of all, we need to use this one over here, right? So arc of the smaller circle is 9. A smaller sector is 9. And 9 arc is r times theta, r times theta, r times r times theta. So arc is r times theta. So this is arc is r times theta. So arc is 9 centimeters long, and then r is 11 centimeters long, and theta we do not know. So it's 9 over 11 is theta. So you have to find something weird here, right? It goes against your common knowledge because theta here is radian. This is radian. This is not in degrees. So it should have come out as like some degrees, but it's not in degrees because it's radian. Okay, so you want to convert this into degrees if your problem asks you to do so. Then how do you do that? Because so for example, we have 360 degrees is 2 pi, right? Therefore, if you want to put 1 here, then you need to divide 360 degrees by 2 pi. Therefore, 1 is 180 over pi, right? So if you have 1 radian, this is the same as 180 degrees over pi. So if you multiply this, then you get a degree that is approximate to that approximates to this radian here. Well, anyways, we don't need that to solve this problem because you can just put theta as 9 over 11. Although this is not in degrees, you can do that. Well, I will just go ahead and convert this to degrees for you. 180 over pi. 180 over pi. So this is because we are converting radian into degree, right? Radian into degree. Then we need to multiply 180 over pi. Okay? No, sorry. Pi over 180. So why? Because going from here to here, how do you get there? Because if you multiply pi over 180 to this, then you get 360. Oh, no. I'm 180 over pi. 180 over pi. Yeah, I made a mistake. So let me clarify because I cannot really, delete this anymore. Because going from here to here, you need to multiply this value, right? So 2 pi multiplied by 180 over pi, then you have pi, and then since you get the degrees, right? But if you want to, for example, you have 90, then you want to convert this to a radian, then how do we do that? We need to multiply the reciprocal of this one. Therefore, 90 times 180, pi over 180, then you get pi over 2. Okay, so this is from radian to degrees, and this is from degrees to radians. Okay, now 9 over 11, this is a radian, therefore we need to do the first one, 180 over pi, 180 degrees over pi. Then we know that 9 over 11, and then pi is 3.14, and then 180 degrees. So the result will be in degrees. So if you do that, then let's just check the time. Okay, so I'm gonna calculate this. So 9 over 11, right? And then 9 over 11 times 180, and then divided by 3.14. Then you'll get 46.9. 46.9. Oh, sorry. 46.9 degrees. So in degrees, this is 46.9 degrees, 99 degrees. So what this means is, if you want to like